EMU used to be an architectural practice based back home in Italy. And we over the years, we were working on Passivals projects, and we were trying to get better, get more cost effective, get faster, and having a faster implementation of that. And that is how back in 2015, we came across the construction system certification for the Opaque building envelope. And this, I think, has very great potential to bringing Passivals to mainstream and make it more accessible, more understandable to manufacturers, and more accessible to designers, including architects and engineers, in its climate-specific implementation. So this is a repeat of the learning objectives of the presentation, basically understanding the why, the how, and how can that be implemented successfully in Passivals project in different climates. So starting from different Passivals building standards, we have the full-on Passivals as per the international definition. We have the low energy building standard, which is a similar quality assurance process as the full-on passive, but with more accessible targets as far as air tightness, as well as heating and cooling demand. And that is something we use quite a bit on smaller buildings or in colder climate zones, such as project at elevation. And something that is just as important is a passive building standard for building retrofits, which is the NFE standard. Now, each of these is made up by a combination of different targets as far as what the building has to be to achieve in order to be certified. Those include the heating demand, the cooling demand, the primary energy demand, whether you go for the renewable path or the primary energy, the building air tightness, as well as the balancing of the ventilation system. And then there's two other elements, the comfort criterion and the hygiene criterion, that address quality of the building envelope. So the first three are assessed by the whole building energy model executed in PHPP. You can get there also via modeling in SketchUp or in Revit or ArchiCAD via different plugins, which we're going to cover later. But at the end of the day, the whole building model is executed in PHPP. Testing is done on site on the actual building, and that is the air tightness as well as the balancing of the system. Whereas the two criteria at the bottom are modeled for individual components of the building envelope, typically via finite element software that is ThermaBridge model. And so of this process, part of that is project specific. Each project has its own design, orientation, site. So unless you have a very replicable design over, for example, the exact identical building repeated multiple times over a development, this part is hard to replicate. The testing done these testing are done on each individual building, so you cannot take the values for air tightness from one building and apply that to the next one. You need to test each individual building. Whereas this finite element software modeling for the comfort criterion and the hygiene criterion can actually be replicated, and that is the beauty of designing high performance components of the building envelope that can then be applied over different projects. So the reason to have this kind of third-party certification is to have a third party assessing the actual performance of a product. And so specifiers and architects can actually look at databases and find products that are comparable as far as performance, and that performance is evaluated by third parties. There is a climate-specific suitability, and we're going to see in a moment what this means. But that means that component can provide enough thermal protection for a specific climate to have comfort, as well as to avoid mold and condensation. For example, a window that is suitable for climate zone 5 may have condensation issues in climate zone 7. So the level of thermal protection you need is climate specific. Having that kind of pre-certified component lowers the costs of getting to Passivals because you dilute the cost of modeling over multiple projects, as well as you can allow a broader market to achieve Passivals because it flattens the learning curve. So we cannot really expect every single professional to be extremely articulate in building physics modeling, but they may understand the certificate and let the modeling for experts. So something that is more commonly known as far as certified building components is windows. You get a certificate for a window. It has a stamp of PHI. You see in this image here, it shows a profile of a window. It shows a triple pane. And so there's a common belief that a triple pane window equals Passivals suitable, and a Passivals window needs to have triple pane. And that assumption is partially true and partially false. So the certificate actually shows the comfort criterion for a specific climate. And that provides the thermal protection you need to have thermal comfort inside the building. It also shows the hygiene criterion, which is there to avoid mold and condensation. So if you have these two parameters checked, the component is suitable for a certain specific climate. In this case, the cool temper climate roughly corresponds to climate zone 5. Now, something that is less known is that you can have building components that are certified for milder or colder climate zone. This certificate on the right-hand side shows a double pane window, which is certified for milder climate zones. So you have a warm climate, which is the equivalent, roughly speaking, to climate zone 3 in the US. And you have the criteria for comfort and hygiene called out on the certificate. So if you're working in Texas, you should be looking for the window on the right-hand side of the screen. You should not really be looking at triple pane glass, because that may be overkill. And in having this kind of knowledge, you can fast track your product selection as well as maintaining cost in check. Now, the same can be done for construction systems. This image shows the certificate of EcoCore panelized system. The image is actually, the photo is actually from a project we're working, a construction system we're working in Australia, but it's kind of a similar approach for panelized construction. And a certificate calls out for the hygiene criterion and the comfort criterion, just like a window. We're gonna see in a minute what other requirements are covered in the construction system certificate, but that is kind of the same approach, verifying the requirements for each individual piece of the building envelope so that you can have thermal comfort and you can have avoidance of mold and condensation. And this is what a certificate looks like. There is no actual details shown to protect the IP of the manufacturer, but it calls out specific performance data that the Passivals Institute verifies for this component. So you see the psi values and the temperature factors for each individual junction. The criteria, this is a link where you can access the PDF of the criteria for the construction system certification. And this is a table that summarizes by climate what requirements are necessary for hygiene, that is avoiding mold and condensation, achieving thermal comfort, and then having other criteria, including efficiency and moisture protection, that all build the criteria for component certification. This applies not only to panelized systems, but also to systems that are built on site. The photo on the right-hand side is the very first construction system that we worked on certifying back in 2015, and it is a SiteBuilt masonry construction building, and I think it was the first one to be ever certified for warm climate. So the same quality assurance process applies to off-site fabricated buildings as well as site-built ones. Applies to new construction as well as retrofits. So this is something that basically takes the quality assurance of the modeling of these components up to the manufacturer rather than approaching them on a project-by-project basis. And in order to do that, you want to make sure that you have your system down. So as a manufacturer, you want to go through a couple of successfully built Passivals buildings before you jump in and standardize your construction system. So you go through some interaction as far as buildability, thermal modeling, moisture management modeling, and then you identify what works the best for you as a construction system. And once you do that, you can get into certification. PHI executes more accurate performance, more accurate energy modeling that are typically required in a project certification. But that allows to have users of this information down the line better data and more reliable data as far as performance and quality assurance. So in this case, on the right, you see the psi value and the FRSI value calculated for this junction. There's a database. I put the link on the bottom right of the slide if you are interested. And this is the page for the US-based construction system. Right now, there's only panelized construction system, but this can be expanded to SiteBuilt or modular, fully volumetric modular construction systems as well. So the question we typically get is, if I do use a certified construction system, will my building automatically be Passivals certified? The answer to that is no, because it's like playing with the Lego and not following the instructions. So the individual pieces of the Lego, that is the construction system, are per se verified. But there's an integration needed on the architectural side and the quality assurance side that we're going to see in a second that is still needed. So what the certificate gets you is a list of and the performance of the pieces of the Lego that the designers and architects can assemble in their design, and the quality assurance that comes with it. We have quality assurance in terms of performance. A third party actually certifies the R values and the U values of the construction system. We have the comfort criterion and the avoidance of mold condensation by means of the hygiene criterion verified. And there's a reduction in the cost of the consulting scope for individual projects because all that thermal bridge modeling is taken care upstream. And typically, if you're working with a manufacturer that has put in the effort and time and money to certify the construction system, typically they are much more committed to achieving the Passivals quality than the competitor that have not gone through this quality assurance process. So the implementation in the design, as I mentioned, the construction system itself will not get the building certified. Each building has to be modeled in PHPP to verify the actual performance. But the good news is that within PHPP, there's a database of the pre-certified components that you can find and load information directly from within PHPP. The same happens in Design PH, that is the SketchUp plugin for preliminary modeling of Passivals buildings, as well in BIM 2PH, that is a plugin for BIM software such as Revit, ArchiCAD, and others. So all of this information, once a component is certified, this information is pre-populated in the software so that architects and specifiers can pull up that information and have that information readily available. So once the building is modeled, you have the usual construction quality assurance in terms of construction, balancing the integration system, the blower door test, and this leads to the certification of the individual building. What the construction system does is streamline the process and reduce the consulting fees. Something that we've done as our own R&D as Immune, we have created a pilot program, and the purpose of that and the method of that is based on the construction system approach. And what we are trying to do is to bridge the gap between the builders coming through our training and the first building that they ever built. So we want to enable the average builder to build passive using off-the-shelf products and using SiteBuilt stick frame construction, which is what they are most familiar with. So on the right, you see two typical details. One is at this slab edge at the exterior wall. One is developed for Climate Zone 5. You see the thermal break and the under slab insulation. And the same detail for Climate Zone 2 has no insulation under slab and no thermal break. So there's a climate specificity to this that makes projects more achievable and more affordable. We try to implement the same construction method approach in reducing fees, and eventually we are aiming to have this construction system certified with PHI. We talked about the construction system as a whole, but within the same protocol, you can certify individual components of the envelope. For example, you can have the certification of a roof system, of a wall system, or a floor and slab system without certifying the whole construction system. People and companies that should consider this include panelized manufacturers in timber framing, SIPs, CLT, fully volumetric modular, roof construction system, insulation manufacturers, ICF or foundation systems, as well as production builders. Basically, anywhere you have the same construction system that is replicated on a consistent basis, this is just part of your product R&D. And once you have this completed, you just repeat the same assemblies and details over and over. So wherever it makes sense to replicate this, the same details and assemblies, this makes sense because it just provides an additional quality assurance verification for your product. Pushing the envelope. So Passivals is a streamlined path to achieving net zero. And in doing so, it requires a greater quality assurance than conventional construction, because the closer we get to zero, the more everything matters as far as performance and durability. And the certification of the construction systems allows for more predictable results and to dilute the consulting fees compared to a traditional approach to Passivals, where all of that modeling is executed and charged to the individual project. That being said, this completes my presentation, and I'm happy to answer questions.
I'm happy to start out, Enrico. One of the biggest questions, of course, is when you're designing in the PHPP, that you're often changing your R values of your walls. Mm-hmm. How does that work with a certified component?
I showed a screenshot within PHPP in the area sheet. You have a drop-down menu where you can pull up manufacture XYZ wall and manufacture XYZ roof, for example. So that would be, you just select those pre-populated assemblies, and they will be, the R values will come up in PHPP. The same happens in Design PH as well as BIM2 PH.
So let's say, so are all the components then a fixed R value in the drop-down menu?
By climate zone, yes.
Okay. So it's fairly restrictive in that sense.
It kind of depends on the type of manufacturer. I know, for example, that Build Smart has incremental steps by 1 inch in their insulation. So it kind of depends on what the manufacturer has come up with their construction system, yes.
Enrico, there's a question from Christian, which I think Mariana answered, but just to make sure everybody gets the benefit of it, regarding the system used in the Australia reference. Mm-hmm. What was that system?
That system is Eclipse Passivals, which we are working on certifying the construction system of, and that is basically, we are talking climate zone that is similar to climate zone 4 in the US. And in that case, we're looking at, actually, it's between climate zone 3 and 4. So we're looking at the equivalent of a 2x6 framing with dense spec cellulose insulation.
Okay.
For the wall, yeah.
What sort of a question that came to my mind was, what sort of trends are you seeing around this? You mentioned production builders, the usefulness mm-hmm. for that. Are you seeing any interest there? Also, we'll start with the production builders and that sort of.
So I've seen trends in panelized manufacturers, because that is fairly easy to understand. In Europe, that is also being picked up quite a bit by insulation manufacturers or manufacturers of factory-made retrofit facade systems. For example, if you have a big multifamily project, you can factory assemble basically panelized system to be applied to the exterior skin of that building. So that has become more popular. The production builder is something that I added there because it makes a lot of sense. I have not yet talked to any specific production developers, but it's basically all of this. The most replicable your design is, the more this makes sense. So it is kind of a light bulb moment when an insulation manufacturer sees this and says, okay, I can actually sell more product because I can show the best practice and have a third party certify the best practice and the performance, you know. So the panelized is more straightforward. The SiteBuilt is more, you know, it is the same exact quality assurance process, but it's less intuitive, I guess, as it is the production builders.
And what similarities or differences do you see sort of around the world? Is there more commonality within the certified components, you know, building systems from one region of the world to another? Or things being more adapted, or is it still pretty separate?
So in the US, we have three certified components in the US. They are all panelized. And I think one of them is more geared towards multifamily. The other two are more like custom homes. In Europe, this has been around for longer. And I think in Europe, masonry is still very present for residential construction. So there's more of that, as opposed to
SiteBuilt.
Yeah, SiteBuilt. Yeah. I have seen one prefab masonry manufacturer from Austria that was brave, but and I've not I've not seen their delivered quality, but it's, you know, just because of weight and logistics, it becomes difficult. I think this is more popular. The more Passivals reaches mainstream, the more tools such as Design PH and BIM 2PH become popular, because that is how you integrate the Passivals upstream. You know, we want to go upstream in integrating Passivals with architects and designers. So if you can get that we try to get in at the schematic design phase, just because once the design is set there, it's very hard to move away from a certain design. So in that case, having that integration of this pre-designed or pre-certified construction system within Design PH and within Revit, for example, makes a lot of sense, because people that are in charge of the building design don't necessarily have the time to expand their knowledge in Passivals finite details, you know. So this is just to say, so something that I go back to is, if you look at architecture in the 1920s or something, architects used to to design windows, literally designing the profiles, and no architect today would design a window. The reason for that is there's an expectation for performance of windows that cannot be met by designing one window or two per year. It takes a lot of effort as far as R&D and to deliver the quality. Now, we are getting there with the construction system. We are learning to approach the assemblies as the one product, not just a sum of individual products. The market is not there yet, but this is where this is going, you know. This is, and actually the guy at Eclipse, he was Devin Parkinson. He made a comment when we were starting the work together. He said, I want to become the envelope manufacturer, not the panelized wall system manufacturer, the envelope, like the whole, you know. So that shifts the focus to the performance of the whole, you know.
So they're certifying the whole structure as a component.
Correct. The whole construction system, floor, wall, and roof. Yes.
And is there customization capable within that? Or is it really like a Sears, like a catalog house at that point?
Well, these are the Lego pieces. So those are still custom homes, and what they deliver is, you know, the quality, the R values, the air tightness, and then you can. So in Europe, for example, there are panelized construction systems that come with pre-designed floor plans. You know, so that is the next step, with more integrated design, less options. but that is not what we're talking about here exclusively. You know,
Right.
that is a subsystem of this. So this is more about you don't get to pick and choose too much about the assemblies themselves, because just like when you buy a window, you don't get to pick and choose where the gasket goes. That is,
Right.
that is the job of the manufacturer. You know?
There's a question along this line, I think, and a bit of a discussion with Mariana from Trevor. Say loves the idea of pre-certified manufactured wall, roof, floor assemblies. Is there any move to pre-certify assembly plans? Say I'm a builder and I want to site build a wall and a roof. And I guess you've kind of spoken to that already, but to build on that question,
to certify a design, like a set of floor plans, like an actual.
Well, no, do you see like somebody using like the floor pre-certified floor system or a wall system, and then doing a custom roof, or
so
so
typically
mixing and matching with the building?
So yeah, this is a good point. What this does is it's a quality assurance to say, hey, me the manufacturer, I am willing to undergo this extra effort to show my quality, and then I think most of these manufacturers can do some customization as far as the assemblies. You know, so this is more the overarching philosophy here, and not even. The certificate does not even require all of the assemblies to be certified. You can mix and match and have, you know, have your certified floor and your certified wall and do a custom roof for sure. Yes. So this comes more down to the manufacturing process of the individual manufacturer than the certification process itself. You know, it clearly, if a manufacturer is producing 100 homes per year, they're going to be less willing or to change the process. But if they're doing maybe 10 custom homes per year, probably yes. You know, so that, but that's more about the production line, the certification.
Sure. So say I was doing a new home and I used the component system, all of it. We're not doing any customization with that. What are the kind of common issues that I might still have in executing? What problems do you see, or things that people are maybe taking for granted?
So
actually hit the full building performance.
For
everybody can remain anonymous.
Yeah. And this is not being recorded, right?
Exactly.
Yeah, no, that's awesome. Yeah, let's do that. For the panel, and this is a little bit where you know, we also use this approach for pre-designed site-built system as opposed to just panelized, right? And so sometimes it takes an extra step for architects, for example, to understand the process, because, you know, if you're using to designing everything, then understanding that the assembly is the product, not the sum of individual products, then there's one extra step typically, because it removes that from the scope of the architect, right?
But you're talking about site build now, right?
Both really, because the same applies to panelized as well and modular, you know.
Yeah.
But other than that, then it really shifts the attention toward the construction quality, you know, because you streamline the design process, and so it really comes down to actually delivering that airtightness and actually delivering that assembly on site, you know.
Right.
Can you talk about a little bit about the pros and cons? Like, I can see on larger scale projects, this can be extremely helpful, but maybe with more custom projects or projects with smaller lots or different kind of foundation systems, you know, you have to coordinate with structural engineers. There's all sorts of other complications, obviously, and costs that come along. What kind of, when people are making decisions on how to go for an Opaque certified component or not, what are some of the things that stand out to you as to it being appropriate?
So for example, the consulting fees for a single family home versus a townhouse for the components are about the same, I want to say. So the cost of a townhouse would be diluted over multiple units if it was project specific. So if I say, hey, I want to design my own walls assembly, and then I want to model that to me passive house, that extra cost will be diluted over multiple units, whereas it will be sustained by the one single family house for the smaller project. So in a way, applying this pre-design process benefits the smaller projects more in diminishing the cost of consulting, if that makes sense. You know.
What about the kind of the development of the components themselves?
That is typically done by the manufacturer. Yes. So when we work with the manufacturer, we typically try to understand what they know of passive house already, what kind of project they've done to passive house level. If they've done any certified project, you know, there is still a lot of confusion between passive house, passive solar, net zero, and close to passive, but not really, you know, so just trying to understand what product they have. But that R&D, it's just an R&D, just like you would have for fire code certification or structural, you know. So it is something that is taken up by the manufacturer, and then it is kind of diluted and embedded in the cost of the product, but over multiple projects.
I'm curious sort of what trends you're seeing on the architect builder side of it. Are certain approaches, I mean, you need to certify to, and addressing the hygiene and moisture criteria and so forth. One thing I'm actually interested in is if you could speak to a little bit about the difference between hygiene and moisture criteria.
Yes.
I'll put you on the spot, but I think people might make the assumption that they're.
And this is, yeah.
And then, but just to follow up, you know, and you know, with the materials, with the building materials, and what possibilities do we see in growth?
Yes.
You know, in the future.
And this ties in, I think, I like that you brought up those two. I think if we look at the market in North America, there's a lot of activity in trying to guess the best assembly or the best wall assembly, detail, whatever. So there's a lot of, I think there's a very shared understanding that code does not really do much in terms of performance and does not do much in terms of durability of buildings. I think that is a given in the market we operate in, which is different from Europe, for example. And so there's a lot of the trend in the market, and I'm getting to the hygiene and moisture. The trend in the market is trying to come up with solutions to address thermal bridging, address air barriers, all of that, in using products that are thought to be innovative, or if they are innovative. Now, there needs to be a structure to evaluating if a solution is good or wrong, right? And that is why we use building physics. And the way we do that, and that is what is embedded and structured in the passive house construction system basically as a sub part of the passive house standard itself, is that we address the risk for mold and condensation occurring on the interior surface of building components by means of the hygiene criterion, and that is done by matching or exceeding the minimum temperature factor prescribed by climate zone. For example, climate zone 5, all of your details and junctions have to have a temperature factor FRSI greater than 0.70. The purpose of that is to avoid mold and condensation occurring on the interior surface, and that is called the hygiene criterion. Another piece of the puzzle is the comfort criterion, meaning that in order to have thermal comfort inside your building, you have to have a maximum temperature gap between the average of the room and the coldest area of 7.6 degrees Fahrenheit. And you do that by climate and by looking at the U values of windows, for example. And you have a maximum allowed installed window U value that in climate zone 5 is 0.15, because given the exterior temperature typically in climate zone 5, that would get you within a temperature difference of 7.6 degrees. So that is the comfort criterion. And the last one that you brought up is the moisture criterion, and that is for interstitial condensation, which is a newer addition to the puzzle. And that is something that can vary quite a bit depending on the type of assembly and type of products that you use. So I think right now there's a trend in using more variable and more vapor open products than in the past. There are products such as smart vapor retarders that can adjust their permeability to water vapor depending on the relative humidity they're exposed to. So basically it's a membrane that blocks vapors from getting into the assembly, but they sense if the assembly is too damp, they let that vapor drive evaporate back inwards. So there are some very smart materials out there, and that is becoming more common, luckily, on the market. It is difficult to put a price tag on the ROI of those because your building becomes more durable. You have more moisture resiliency, but you cannot really put a price tag on that. You know,
that actually seems like one of the biggest benefits is having an understanding of those condensation issues and that vapor control. I think that's more elusive often than just even our values of thermal bridging for a lot of people. So it seems very helpful. Hey, Trevor asked a really interesting question, was that is it possible that like a manufacturer takes like a nice system that we all would want to use or maybe even use and patent it and potentially keep us from building similar walls, do you think? Have you seen anything like that, either in Europe and the United States?
I've talked quite a bit with patent lawyers to cut to the chase, and that it's basically close to impossible to patent a wall system, you know, unless you have something that is extremely unique. So that is very unlikely, in my opinion. Yeah.
Is that okay? And what do you think about people modifying? Is there a place where you can modify the systems at all?
Well, the whole point is to not modify them, because if you modify them, you have to redone the modeling. And basically, that is the self-critique we came up with in like 2014, 2015. That is where we were doing a lot of modeling. And if you like to mingle and tweak things a little bit, the bang for the buck is very low. You get a very little benefit for a decent amount of time and knowledge needed in the modeling. So the whole point here is to try to, it's like going to your sports store and buying a jacket. You know, you buy a jacket to go skiing, or you buy a jacket that is for mid-season, and that is the R value that you get, right? You'd imagine if you were to have that jacket being tailor-made, that would be significantly more expensive because somebody has to spend time and tailor that onto you. And that is, the tailor-made is how we approach most of Passivals projects these days. So really we want to start looking at the construction system as the jacket and pick the one we need. And manufacturer will have multiple incremental steps in the R values, but if they have an R40 and R50 walls, you don't want to mingle and get to R45 because that extra cost is not worth the time and effort, really.
A follow-up question on the materials. Do you see anything? I mean, we see a lot of the wood construction and you see the masonry in Europe in the site build. Do you see anything moving, somebody trying to figure it out with metal or other materials?
Yes. So this is perfectly applicable to metal frame construction. Just it requires more effort in mitigating thermal bridging. So, but there are, especially for commercial application, there's definitely metal framing or hybrid systems that use metal for sure.
And do you see that like happening in larger scale buildings? Like, I think you showed an image of quite a big building there.
Yes.
One of them.
So in Europe, there are like insulation manufacturers in Europe will have their own certified system for larger commercial buildings, and that becomes part of their marketing, saying, "Hey, this is my detailed booklet, and this is the certification for all the thermal bridging." So that is definitely something that is more articulated and expanded upon in Europe for sure. I look forward to. What's that?
Are they in the US as well, or?
Not yet. That is something that I look forward to the first manufacturers to pick that up in the US, because this is something that if you have your insulation board XYZ, they're going to have best practices on how to install those. And the compared to fire code certification, this is considerably more affordable.
Mm-hmm. Great. Andrew, other questions? And I need to look through.
It looks like people are really good at answering questions online.
Mariana's going through it, and Edward.
Yeah. So what's next? So how does this fit in with the larger kind of pre-manufactured movement? Like you showed an example, Enrico, of an entire, kind of unit, looked like a stackable apartment kind of building. Is that something that can fit in quite kind of cleanly with kind of the larger pre-manufacturing industry, especially when we're talking about scale buildings?
Yes. So if you think about that, those volumetric modular manufacturers have their own wall assembly, which at this stage most likely have an R20 wall because it complies with code in most climate zones. But to comply with Passivals, for example, in climate zone 5, all you need to do is probably add a few inches of insulation on the outside, and you can do that very effectively, by climate. You can say, hey, I have a climate zone 4 package or climate zone 5 package for Passivals, and that could be maybe 2 inches for climate zone 4, maybe 4 inches for climate zone 5. But that compared to the process and quality assurance that modular manufacturers already have in place, the R values is a secondary concern, and the air sealing, it just needs to be adapted to the way they put together the modules, but they already have the idea of having something that is pre-designed and assembled on site. So as far as quality assurance, that is much easier a much easier upgrade compared to a builder that has never done this before and is just used to building 2x6 wall on site, So the learning curve is kind of depending, but long story short, this can be applied to steel frame, straw bale, hempcrete, masonry, you name it, because it's based on physics, just like the rest of Passivals.
In fact, it is right now, right? We have a straw certified component out in the market. So, yeah.
Exactly.
Fantastic. This is great. Super exciting to see this and to dive into it a bit more. I know it's a bit of a mystery for a lot of folks, and this was illuminating to me, and definitely I think along with a number of people appreciated any number of your analogies, Enrico. You're very good at explaining this and making it accessible.
I found it very opaque.
I have to pull out my box of Legos.
It is, years of teaching builders, so it is, in class, we talk about elephants and mice and so it's try to get that image in the head, and then they get it. So
wonderful. Well, I don't see any other questions on the chat. I don't know if there's any particular, when we were talking earlier, Enrico, you mentioned some deep dives in any number of directions. We don't necessarily need to draw this out, but I know you've got an audience that probably would appreciate, whatever. Was there some aspect of this that you find, when who is coming to you? Is it builders that are primarily driving this component certification, or is it architect designers?
So this is something where we typically are brought to the table by a builder or an architect that uses a panelized system, and we help them expand on that and meet Passivhaus certification of the component after we had them building a couple of buildings to Passivhaus standard, just to get their head around air sealing and all of that. For example, back to the Eclipse Passivhaus, they wanted to get started 2 years ago, and we said no because they had not yet built an air sealed full building. So we said, no, go back, build a couple, and then come back to us. And they did, and we are modeling right now. Yeah, so, and this ties into why passive and why training and why components. People want to build better, and the expectation of buildings is higher than just code. And something that is very lacking in code is proper moisture management. In terms of air sealing, you are required to have an ACH value without really telling you how. And building code is still based on UPI method, which does not really account for an ERV system or an HRV system and whatnot. So people that come to us for whichever reason are typically driven by the will to do better in terms of servicing the clients better for comfort, durability, air quality, and avoid the liability of the unknown, that is the moisture management.
That's a great point.
Yeah.
That whole risk management to get rid of all the unknown unknowns.
Correct. So this is just another quality assurance of something that you standardize, and you do it one time and you keep it for the next 5 years, unless there's some major change needed,
Right. Architects have to stop wanting to reinvent the wheel on every project, right?
Yeah. So mingling is bad. Mingling this something that I talk about my own experience of. I'm a huge mingler, like a huge, and at the end of the day, if you look at the numbers, the changes and the improvement don't offset the cost and time of trying that. So in the R&D, we try to have to have them get their hands dirty with air sealing and whatnot, and then we try to have a statistical approach to see what's the typical size of the building, what is the typical climate you work with, so to feed that information upstream before we get into certification, so that you don't have to touch it for another 5 years or so.
Fantastic. Yeah, the upstream analogy is so important with everything that we do.
An analogy that Mariana loves to go back to is looking at the aerospace industry, and you don't build an airplane and then try to fly it. You model it multiple times over and have it failed a cajillion times until you get it right. And this is kind of bringing that virtual prototyping approach to the building. So that it makes a lot of sense, and it's just about time this is entering the construction industry mindset.
Do you see any tendencies around these systems, building systems, towards, their execution, like, slab on grade, no cellar, or on posts, or different approaches to building? Is there an inclination, or it's pretty much anything and everything?
It kind of depends the type of project a manufacturer typically works with. If manufacturer typically builds commercial buildings in New York, they are going to have a certain typology that is their go-to. And as I mentioned, the certificate is more of a mark of quality, and then they can have other assemblies that they don't typically use. So they may exclude that from the certificate, but apply the same quality assurance throughout the process, and maybe have the modeling done also on those assemblies, but not include them in the certificate. So this is more about, different regions in the country use different methods, like basements, very common in Colorado. My understanding is that they are rare in California. So if a builder or a manufacturer mostly works with California, basement assembly, not a thing. That's my guess. But that's more responsive to the market, not really the certification.
Great. Do you see anything? Do you have any inside dope on, like, any the latest and greatest, and how PHI may be looking at building system certification? Is it, I'm interested too, was SiteBuilt always a part of the building system certification, or is that relatively?
At least since 2015, that is the first one we ever worked with. So
Been a while.
yeah, it's been a while. And honestly, that was the really first time I looked at that. So I don't know, maybe they added that January 1st, 2015. I don't know. But no, I think this is a well-established program. I think it ties so well in with the preliminary design plugins, Design PH and BAM 2PH for Revit, because it enables a much broader market to use Passivals as the design tool without spending the time on mingling different assemblies. So in the BAM approach, as well as in the Passivals approach, you are faced with a lot of details needed up front. You know, if you want to do a concept design with ArchiCAD, at least back in the day when I was using ArchiCAD for architecture design, it was hard to do a concept design because you had to build up your assembly. You had to be very specific at a time where you have no idea. And same goes with Passivals without this approach. You know,
Right.
You may be tangled into details at a stage where you don't have to. So this approach is beneficial also for that.
That's fantastic. Well, we're at time. So this has been great. Thank you all for coming. Enrico, thank you for a fabulous presentation. Good discussion. Thank you, Andrew, for helping host, and to Passive House Rocky Mountains and everybody. Hopefully people get involved in their local chapters. And if you don't have a local chapter, feel free to start one. We'd love to hear from you. All right. Thank you, everybody. Have a great day.